Well, welcome back, everyone. What I'd like to do now is talk about another very basic, preliminary, often epidemiologic study called an ecologic study. Well, first of all, what do I mean as an ecologic study? Sometimes they're referred to as correlation studies. Now, Marcello is going to be talking about correlation coefficients later in this course. And a correlation coefficient is a measure of association between two factors, two variables. He'll be just talking more about that later. Here, by correlation study, I mean it's an association study. It's associating two characteristics of people, whether they had a particular diet and whether they might have had a particular disease. But the point that makes this different from other types of studies that we'll be talking about in future lectures is the ecologic studies examine associations between, say, an exposure and a disease on a population level, not on individual levels. So for the previous lectures, we've been looking at data from the Framingham Heart Study. And I've been able to show you how many of the smokers developed coronary heart disease. There, the unit of analysis, the unit of measurement, was the individual person, and whether that person was a smoker or not, and whether that person developed coronary heart disease or not, indicated what cell they fell into in the tables we've been looking at. Here, when we talk about ecologic studies, we're talking about data that's not measured and analyzed on the individual level, but it's collected and analyzed on a population level, where we're looking at groups of people and comparing two characteristics on those groups of people. So it's descriptive, but it's on a group level of description. So for example, I want to show you an example that I put together using data that's available on the web, public domain data, from our Centers of Disease Control, using something known as the Behavioral Risk Factor Surveillance System, the BRFSS. And I'll talk about that in one of the upcoming lectures in this sequence of lectures. But basically what it is, it's data that reports the prevalence of a risk factor, or the prevalence perhaps of an outcome in a group of people, and it's broken down by which states the people are living in. So what I was able to do from looking at two different sources of data collected from the BRFSS was to look at the prevalence of depression in the period of time of 2006 and 2008 in the 50 states of the United States. And around the same time, using another source, again using data from the BRFSS, I was able to look at the prevalence of obesity, this time in the year 2011, by state, again separately from each of these individual states. So imagine what the data is. What I have for each state are two measures: the prevalence of depression, how much depression there is among adults living in that state, and the prevalence of obesity, what the percentage of obese people are living in that state. And I have 50 states, so that's what your data is going to be looking at, each state having two pieces of information: prevalence of depression and prevalence of obesity. What I decided to do was to describe that data by building a scatter plot. Each of the points in this plot is describing the results from a particular state. On the vertical axis, we have the prevalence of depression. On the horizontal axis, we have the prevalence of obesity, and we have 50 points there, essentially 50 points, 1 point for each state, plotting that particular state's values for prevalence of depression and prevalence of obesity on this YX or this XY axis. And what I've superimposed is a line, a regression line, that sort of describes the general tendency that we see in this data. That in general, that the more obesity there is in a state, we see a corresponding increase in the amount of depression in that state. It's what we call a positive correlation. And again, Marcello will be talking about correlation coefficients later in this course. So that's the general finding of the study. On a population level, there seems to be association. The more obesity there is in a state is related to the more the state has a higher prevalence of depression. Now, that's the main conclusion we could reach, is that positive association, this positive correlation, that states that have higher prevalence of obesity also have higher prevalence of depression. Well, that's great from a public health description point of view. It identifies regions which have two unfortunate characteristics, high depression and high obesity. But really, what I'd love to be able to answer, and the question is, do these data allow me to answer, are different questions. Is obesity a risk factor for causing depression, or vice versa, since this is cross-sectional data collected essentially at the same time, is depression causing obesity? But I want to answer that in individuals. So the fact that I see a positive association between obesity and depression on a population level, does that automatically imply that if I did the types of studies I was describing in the previous lectures when we used the Framingham data set, or the types of studies we're going to be describing in future lectures when I talk about other types of study designs, can I automatically conclude that an association I see on a population level, in this case, the more depressed or the more a state is, the higher amount of obesity it has, and vice versa, can I infer that association carries over to individuals? People who are obese tend to be the same people who are depressed, and vice versa. And the problem is you cannot automatically jump to that conclusion, that associations we see on a population level imply associations you would see if you captured data on the individual level. And to try to show that, I'll give you an example, a hypothetical example in a minute. So what we're talking about this are associations we're seeing on a population level, and we're asking, do they hold on an individual level? And the example I'm looking at here is the problem is we don't know within a state that the people who are obese are the same people who are depressed, and vice versa. And that refers to something called the ecologic fallacy. That the mistake we make from ecologic data like this, where we incorrectly assume that associations we see at a population level automatically exist on an individual level. And to show you how that can happen is this is hypothetical data. Let's suppose each of these boxes represent a different region. Or if you want, a different state. You know, we have a state A, a state B, and a state C in our data set. And in each of these three states, there are 10 individuals, 10 different individuals in each of the three states. So state A, the top table here, contains 10 individuals. 4 of them are obese. That's what the row variables refer to as whether you're obese or not obese. And 4 of them are depressed. So if I asked what's the prevalence of obesity in state A, it would be the 4 people who are obese divided by the 10 people who are in state A. 4 over 10 gives me a prevalence of obesity of 40%. What's the prevalence of depression in state A? Well, I have 10 people again. Now 4 of them are depressed. 4 over 10 would be the prevalence of depression. That also is 40%. If I move to state B, the middle box on this slide, I have a different 10 people. 5 of them are obese and 5 of them are depressed. If I say in state B, what's the prevalence of obesity? It's going to be 5 out of 10 or 50%. What's the prevalence of depression in state B? It would be the 5 depressed people over the 10 people in state B. Again, that's 50%. Okay? Now let's move on to state C. A different 10 people. 6 of them are obese, 6 of them are depressed. What's the prevalence first of obesity in state C? It's 6 people out of 10, 60%. What's the prevalence of depression? It'd be 6 people out of 10, 60%. So on the population level, what are our conclusions? We see as the prevalence of obesity increases as we move from state A to state B to state C, we see a similar increase in the prevalence of depression. It goes from 0.4 to 0.5 to 0.6. So on the population level, the ecologic study level, we're seeing a positive association. The more depressed the state is, the more obese a state is. Now, does that imply that same positive relationship on an individual level? Well, I can do 3 separate studies. A study just using the individuals from population A, just using the individuals from population B, just using the individuals from population C. So for example, I can look at the top table And this table is of the form which we had in the previous lectures where we measured things like risks and risk ratios, odds and odds ratios. Let's measure the odds ratio, the odds of being depressed among the people in the first row, the obese people, compared to the odds of being depressed among people in the second row, the non-obese people. So the odds ratio of depression now among obese people. We have 4 obese people in population A. 1 of them is depressed. 3 of them are not depressed. The odds of depression among people who are obese is 1 out of 3. What's the odds of depression among people who are not depressed, who are not obese, excuse me, in population A? We have 6 people. 3 of them are depressed. 3 of them are not depressed. The odds there would be 3 out of 3, or 1. If I calculate the odds ratio, dividing the odds of depression among the obese people, 1 out of 3, divide by the odds of depression among the non-obese people, 3 out of 3. 1 out of 3 divided by 3 over 3 would give me an odds ratio of 0.33, a negative odds ratio, suggesting that obesity, the people who are obese, have a less odds of being depressed than the people who are not obese. If I do the same calculation in population B, look at the odds of depression among the people who are obese, it's going to be 2 out of 3. The odds of depression among people who are not obese in population B, it's going to be 3 out of 2. If I divide 2 out of 2/3 by 3/2, I get an odds ratio of 0.44. And finally, if I look at population C, the odds of depression among all the obese people in population C is going to be 3 out of 3. The odds of depression among people who are not obese in population C is going to be 3 out of 1. That gives us an odds ratio of 0.33. So notice within each state, we see the opposite direction of the association between obesity and depression that we saw on the population level. On the population level, there was a positive association. The more obese a state was, the more depressed the state was. On the individual level, we see the opposite message. Obese people have less depression than non-obese people. Their odds ratios are less than 1. That's what we mean by the ecologic fallacy, that associations we see on population levels do not necessarily imply the same associations on individual levels. What are these ecologic studies good for? They're good starting points. Population data is usually routinely available, free on the web, like I did in this study using data from the CDCs. They can look at associations on population levels, and more often, those associations we see on population levels will reflect associations we see on individual levels. But it doesn't always happen. So just remember, ecologic studies have the potential shortcoming as giving you an association that might be opposite, as we see in this hypothetical example, to what you'd see on a study using individual people. And it's a study on the individual people that we're more interested in. We want to know, for example, if obesity increases, say, your risk of developing depression. And to answer those questions, we need data on individual levels. So the next time we come, I want to talk about another type of study design. Again, it's a very basic study design, but it does involve individual data. So the next time we get together, I want to talk about cross-sectional studies. See you then.